Hi, everyone. So in this video, I'm going to go over a representative sample of the practice questions that I gave you last week. So let's start with 2A. So check the following argument for validity using truth tables. Okay, and the argument is P, therefore P. So I like to start by just putting it into this form. We have the premise at the top and the conclusion at the bottom, right? So what is a valid argument? It is An argument is valid if it's impossible for the conclusion to be false, given that the premises are true, right? So we're going to assume that this is true. Okay, so I'm saying using the truth table. Okay, so we have P, right? Uh, P can be true or false. And then we have P or P. And actually, we see that we only have P here. So if P is true, then it's true or true, which is true. And if P is false, then we have false or false, which is false. So if you still have trouble with this, then please go back to the other video lecture where I go through the or the disjunction truth table. Okay, so now at the truth table, we have to look, okay, where are the premises true? Right? Because that's how we're going to evaluate validity. We have to assume that the premises are true, and then we see, are there cases where the premises are true, but the conclusion is false? And so the premise here is P, right? And it's true, so maybe I can even use a different color. So it's true. So this is the only case we care about. So is it valid or not? So take a second. And yes, it is valid because the conclusion is true, and it's impossible for the conclusion to be false given that the premises are true. If the premise is false, then the conclusion is false, but we don't care about that to determine validity. So it is valid, and we have checked it. Good. What about the case where the argument is P or Q? That's the premise one, and the conclusion is P and Q. Okay, so here we might be in a tougher position, right? Because we have P and Q. It's not as easy as before. So let's put P over here and Q. And remember that we have 4 possibilities. So P can be true, true, or false, false, right? It can be just true or false. And we have every possible combination between the two. So we have this. Okay, so what is left now to do? Well, we want to look at P or Q and P and Q. Okay, so P or Q is what? It's true because P is true and Q is true. So true or true is true. True or false is what? True. Right? You only need one of the disjuncts to be true for the whole disjunction to be true. Similarly, false or true is true, and false or false is false. So what about the conclusion, P and Q? So again, we don't look at this for now. We just look at P and Q. And then we say, okay, well, it's true and true is true. True and false. If this is false, right? True and false is false. False and true is false, because it's a conjunction. And false is false. Okay, so we have the truth table. And remember that we care about cases where the premise is true, and we want to ask, is it possible for the premises to be true and the conclusion to be false? Is that possible? And if it's possible, then the argument is invalid. Okay, so we have the premises are true in this case, and in this case, right? So now it's a bit more interesting. We have 3 cases where the premises are true. And is there any case where the premise is true, but the conclusion false. Yes, there's one here, right? True or false. And that's enough to tell you that the argument is invalid. But similarly, there's another false here. So you might say it is possible for the premises to be true, yet the conclusion to be false. Therefore, the argument is deductively invalid. Okay, let's move on. Okay, what's the truth table for this complex statement? All right, one more truth table. So how do we start? So we start by looking at where we look at the simple statements we have, and those are just P and Q. And let's start again by just putting true, true, false, false, and true, false here. And now we look, okay, what are the complex statements in this? We're slowly going to build up the truth table to give us the full truth table of this whole complex statement over here. Okay, so the next simplest one that we see is this not P, right? Not P, and we also have not Q. So let's start with not P. Not P, then we look at the table for P over here. So it's false, false, and true, true. Right? And similarly for not Q, we look at Q over here, and we see true, false, true, false. So it's just the opposite, so false, true, true. Okay, so we have the not P, we have the not Q. Let's do not P and not Q. Okay, so now we have not P and not Q. So just a little reminder that this little hat is the same thing as the ampersand. So this is just an and. Okay, so for this, we just look at the truth value of these two. So we just need to look and say, okay, false and false, false and true, true and false, and true and true. So we only look at these tables to determine whether for the not P and not Q. So here we have false, right? False and true is false. True and false is similarly false. And true and true is false, true and true is true. Okay, so right now we've established the truth value of this whole thing. Let's look at this one, right? So we see that there's a parentheses between the P or Q over here. So let's look at the truth value of P or Q. P or Q. So now we have to come and look over here again. So P or Q. So remember, P or Q is true just in case one of them is true. So it's going to be true, 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 false, right? I'm looking at these two tables over here. Okay, so now we're not done yet with this whole left side because we see that there's a not in parentheses this whole thing. Okay, so we want to know the truth value of not P or Q. Right, you can imagine that this is just to the side, but I don't have enough space here. But now we're just going to look at this table over here. This is what we care about. So not P or Q is going to be what? So we have true, 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 false. And we're saying what's, right? You can imagine that this is just R, and we're asking what is not R? It's the same thing. And so it should be quite easy, right? It's just false, 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 true. And now we have the whole, this whole left side. And all that is left is the disjunction between the two. So we have all the ingredients. So we have not P or Q. I'm going to rewrite the right part, which is not P and not Q, which is rather, I'm just recopying what's over here. So it's false, 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 true. Okay. And these look the same, right? And so we're going to do or, and now, right, just for simplicity, I'm going to call this, let's say A, and call this whole thing B. And really the thing we're asking is, what's the truth value of A or B? And so it's false or false is false, false or false is false, false and false, or false is false, and true is true. And so we're done here. Right? Because A is this left side, A is over what's over here, and B is not P and not Q. And so we're done. Okay, so this is the last problem I'm going to go over. And so suppose you and an alien scientist are presented, right? You're walking around the forest and you're presented with like 3 brown unlabeled boxes. In the first box, right, you might say, in box 1, you see that there's a shoe, a black shoe, right, when you open it. In the second box, I think I had, okay, I'm back. Okay, so in the second box, there is a green bottle. And you're asked to predict the next box. And suppose that we say that the alien says, oh, these are schmalks, right? And when the alien opens the third box, it says, oh, look, I was right. It's a schmalk. What could a schmalk be? And so you can define a schmalk to be, right, actually either a black shoe or, right, so it's a disjunctive definition like the GRU example that I gave you in class, a black shoe or a green bottle, or, and the third or can be anything else, right? So whatever you pull out or the alien pulls out, you could put that in it. So let's say that the alien sees a, let me think, an orange phone. Right? Or an orange phone. And if you define a schmalk like that, then the alien who, let's say the alien already has this in its head as a concept, a schmalk, which is just 3 different things connected disjunctively. The alien is walking around while you walk around and you say, well, or the human scientist walks around and says, oh, a black shoe, a green bottle, orange phone. It's kind of hard to see a pattern here. Whereas the alien scientist is saying, based on their language, is saying, oh, look, a schmalk. And then they open the second box and they say, oh, another schmalk. So they open the third box and they're, I bet there's a schmalk in here. And they look and they see an orange phone, which is a schmalk, and they say, oh yeah, I was right. I have a schmalk. Okay, so that was a few of the selected exercises I went over. I hope this helps, and I will post some new exercises this weekend. Bye-bye.